Good evening all of you. Audio video clear, please mention. So welcome all of you, welcome to this course, welcome to this lecture on counting of polygons. It's a topic where it is mostly reasoning type question, but some idea of geometry is also needed. That is why I'm taking this topic after the geometry lecture. Please invite all your friends, let more people join. We are meeting after 4 or 5 days. So let others know that the live class have started so that they can attend live itself. Those who cannot watch live, recording will be available in this channel. Share the video link to your friends so that they can watch at least as recorded video also. And those of you want printed study material of CSIR-NET Part A, this is currently the bestseller book for Part A section, and we are the authors of this book. And the latest 7th edition is available in Amazon and Flipkart. And our other playlist also we recommend to you for those people who want to learn for GATE General Aptitude. Our free GATE course is available. Those who are preparing for UPSC, our videos on UPSC exam or CSAT also is available. And for CSIR-NET, other playlist also you can refer so that you can practice more questions before exam, especially the PYQ courses where we discuss the latest previous year questions of June 2023 and September 2022. Last 2 years previous year question papers are discussed in detail in these playlists so that you can refer. And speed maths or Vedic math lectures are available in these playlists. So these are our other resources or other videos in this channel, and other free resources are available in Telegram channel, Telegram group, WhatsApp group, and in our website christyvarghese.in. Okay, so let us start today's topic. Hope all of you have shared the link to more people so that more people can join now. So counting of polygons. What is polygon? We discussed last class, and the major polygons: triangle, square, rectangle, parallelogram, rhombus, trapezium, pentagon, hexagon, etc. You already know about it. Based on this, questions are asked, or to count these polygons, questions are asked. There is no much theory on this chapter because it is mainly about counting properly, counting without making mistakes. So it is more of a chapter where we discuss through previous year questions itself. The same type is asked in GATE exam also, UPSC exams also, and different competitive exams. This counting of polygons is asked. So let us see first question. With question itself we will discuss more about it. Try this question and answer it in the chat what answer you got. This was asked in CSIR-NET exam September 2022. So all of you make a try and post your answer in the chat. Okay, so we'll explain number of rectangles in the given figure. Some of you got an answer. Let's see whether it is right. Rectangle is the polygon asked here. So let us count it one by one. Look at this image. I will call this basic rectangles R1, R2, R3, R4, R5, R6 and R7, the non-overlapping ones. That means the rectangles, the individual rectangles that you can see directly. This one, this one, this one, this one, this one, this one, this one. These 7 rectangles I am calling R1, R2, R3, R4, R5, R6, R7. Now the combination rectangles are there. Combination rectangles also you need to count. What are the combination rectangles? R1 and R4 will make another rectangle. Now R1 and R4. R3 and R6 will make another rectangle. R3 and R6 will make another rectangle. These two. R2 and R5 will make another rectangle. R5 and R7 make another rectangle. R2, R5, R7, these three together will make another rectangle. Then R2, R3, R5, R6, R7. That is all these 5 rectangles together, you can form one more rectangle, that is these 5 rectangles, and then these 5 rectangles will make another rectangle, that is R1, R2, R4, R5, R7, and then the whole rectangle, the full rectangle. Don't forget to count that. So adding all these, you will get total 15 rectangles. So option C, 15 is the correct answer. All of you clear? Please respond. Clear or not? So that is how questions in this chapter is asked. Sometimes questions are asked to find the number of rectangles, sometimes triangles, sometimes parallelograms. So I will show you different varieties. September 2022, this was another question. Try this and post the answer in the chat. Okay, some of you already got the answer right. Due to lack of time, I will start explaining. So here, if you count the non-overlapping rectangles, 1, 2, 3, 4, you can see the non-overlapping rectangles. And then the combination of it, just like the previous question, you can find the combination ones. Which are the combination ones? 5, 6, 7, and then the whole rectangle 8. It is comparatively simpler question, so option C. This is directly asked in CSIR-NET exam like this. So it is actually easy question. Then I will show you a little more trickier question which was asked in June 2023. The latest NET exam, the last NET exam, this was asked. Make a try, all of you. This was indirectly asked. So make a try, all of you. Counting of polygons asked in a different way. Here the count is given. You need to create that situation, and after that you have to follow the instructions given in the question. Make a try. Okay, and while trying, one more feedback I want from all of you. Those of you are watching this live or recorded, how many of you are preparing for GATE exam also? Those who are watching it live now, just mention which GATE exam that you are preparing for. Or if basically we need to know how many of you are preparing for GATE exam, because we are, as I have told earlier, we are planning for some full courses for different exams, like paid courses, which is having more resources, more detailed learning ensured will be those courses. So just wanted to know whether you people will be interested to join for the GATE course. So the plan is to start the GATE course immediately after your CSIR-NET exam is over. And that GATE course is not only for science students, it is for engineering students also, because GATE General Aptitude is common for all streams. Whether it is engineering or whether it is pure science, aptitude section is same itself. So we are planning for this February exam itself, we are planning for a full-length course. As you people, many of you are preparing for CSIR exam also now. That is why we are waiting for CSIR-NET exam to be over. So as the CSIR-NET exam is getting over on December last week, immediately after that we will be starting the GATE course. So whether you will be, that will be a paid course. Free course will be there in this channel. The free course of GATE is already there. Those of you are not able to join the paid course, don't worry, the free classes will be there. There will not be any removal of free classes. Free classes will be there. But those who want a live experience or live class through the paid courses can join the paid courses. That will be an updated version of all the previous courses, that is for sure. So that will be starting from last week of December. So some of you are saying you are interested, and do let your friends also know about this plan that we are starting GATE course, that is targeting this February 2024 GATE exam. So before February 2024 we will be covering the entire syllabus of GATE General Aptitude. English section also, that means verbal and non-verbal ability, both will be covered in that. So this is a special announcement to be made today. So spread the word, let your friends also know that the GATE General Aptitude course will be started soon in this soon through our platform. That will be most probably through the mobile application Christy's classes. The course will be launched. So further updates we will give very soon. So straight lines drawn. Now let us discuss this. Thank you for the feedback. Those of you are watching this recorded also, just mention which subject GATE exam you are preparing for. Just wanted to know the crowd here, that is why. Straight lines drawn inside a rectangle can create multiple rectangles of different sizes. The lines can intersect each other. The minimum number of straight lines needed so as to result in a total of 9 rectangles is. So one rectangle is there. So if this is the original rectangle, one second. If this is the original rectangle, we need to put lines so that total 9 rectangles will be created. So how many lines are needed? You may think that that needs a lot of lines, but it needs only 2 lines. That is the idea. Minimum number is asked. It's an optimization problem. So minimum number is asked. Minimum number is just 2. How? If this is the original rectangle, if you draw a line parallel to the edges and perpendicular to those initial edges, this will create 9 rectangles. How? Now this is a counting polygon question. You can see the 9 rectangles here. The non-overlapping one, 1, 2, 3, 4. Then 1 and 3, 4, 5th one, 2 and 4, 6th one, 1 and 2, 7th one, 3 and 4, 8th one, and the full rectangle, 9th one. So total 9 rectangles you can make from this. Now these are the 9 rectangles, 1, 2, 3, 4, 5, 6, 7, 8, 9. All of you understood this? For that, how many lines we drawn? Question is asking how many lines are drawn. 2 lines only. So the answer is option B, 2. So that was a little different question. The image was not given. You have to imagine the image and you have to make 9 rectangles. So how many lines to be drawn? That is the question. All of you clear? Then this was a February 2022 problem. Last few years, CSIR is constantly asking these kinds of questions, counting of polygon. That is why we are allotting a separate lecture on this topic. So try this question also, all of you. I'll come in a minute. Okay, some of you got an answer. Let's see whether it is correct. So the number of squares here, the polygon asks a square. So how many squares are there in the picture? Let us systematically count it. That's the only thing needed. First, 1 by 1 squares. That means squares formed by 1 row and 1 column. 1, 2, 3, 4 you can see in this grid. 4 here. Similarly 4 in this, 4 in this, 4 in this, 4 in this. So 4 into 5, 20 1 by 1 squares you can find here. 20. Now 2 by 2 squares. Squares formed by 2 rows and 2 columns. 2 rows and 2 columns, that we need to count. How many are there? First we can see vertically 1, 2, 3, 4, 5, vertically 5 in this direction. Now horizontally, listen very carefully. Horizontally when you count, you may think it is 5, but it is not 5 because the middle one was already counted vertically. So don't count it again. So 3, 4 only. So that is what is mentioned here. So 5 plus 4, 9 and 2 by 2 squares only. So 20 plus 9, 29 in total. All of you clear? This was asked in 2022 also, 2015 also. Then one more question similar to this. December 2019 problem. Carefully try this. Okay, some of you already got an answer. How many non-square rectangles? Why it is mentioned non-square rectangles? Because ideally all squares are rectangles. Some people are confused about these statements. All squares are rectangles because square is just a special rectangle. What is a rectangle? Rectangle is just a special parallelogram. A parallelogram whose opposite sides are equal. Sorry, all angles are 90 degree. That is called a rectangle. A parallelogram whose all angles are 90 degree is called a rectangle. Now a rectangle whose all sides are equal is called a square. So all squares are rectangles. That is why it is specifically mentioned here non-square rectangles, because squares are normally rectangles, but those rectangles we don't need. We need only typical rectangles whose sides, whose all sides are not equal, whose opposite sides only are equal. Those kinds of rectangles only we need. That is why non-square rectangle is mentioned. So let us see. Non-square rectangle means this is also a rectangle, but that is a square. That is why non-square rectangle, that is why we can avoid it. So to identify it or to understand it, I have given labels to this A, B, C, D up to L. A, B, C, D, C, D, E, F together, this one is a rectangle 1. This is another one. 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 I am counting the rectangles with 2 squares involved. That itself is 6 in number. 1, 2, 3, 4, 5, 6. Now 3 square involved rectangles are there. That is these 3 together. These 3 together. These 3 together. That are 3 more rectangles. Finally 4 square involved rectangle is there, which is the 4 squares involved rectangle. These 4 squares involved rectangle. So 6 plus 3 plus 1 total 10 non-square rectangles are there. I hope all of you understood this. So option C is the answer. This is another question where quadrilaterals are asked. What is quadrilateral? A polygon whose side number is 4, or polygon which has 4 sides are called quadrilateral. So try this question and answer it faster. If this session is useful, do hit the like button, all of you. That will help this video to reach to more and more people, and take an effort to share this to your friends also who want to learn these topics. These are topics not only limited to CSIR exam, but for other exams also these are needed. So share it with your friends who are learning general aptitude for any competitive exams. Even if the question is asking quadrilateral, here the quadrilateral present are only squares and rectangles, or rectangles in short we can say, because squares are also rectangles. There is no other special type of quadrilateral other than rectangles here. That is why counting the quadrilateral in this question means only counting the rectangles, because squares are also rectangles, or squares will also be counted when we say rectangles. So non-square rectangles and square rectangles, both we need to count here, unlike previous question. So let's see solution. So here we can say first we can label this 1, 2, 3, 4, 5, 6, 7. That means non-overlapping rectangles itself are there. Non-overlapping rectangles itself are there. 7 in number. 7 non-overlapping rectangles. Hope all of you understood the non-overlapping rectangles here. Now, by combining these non-overlapping rectangles, you can find more rectangles. For that, we can label them A, B, C, D, E, F, G up to M. You can label like this. So, A, B, C, D, E, F. That is just for reference. So, now, if you count A, B, D, E, then as I told, the overlapping ones, non-overlapping ones we have done. Now, we can find the common, combining this, you can find the rectangles. So 1, 2, you can find, they are the square rectangles. So 7 plus 2, total 9 square rectangles already here. All of you understood the 9 square rectangles already here? Square rectangles. Now the typical rectangles we can count. 10 will be there, 10 typical rectangles will be here, because 1, 2, 3, 4, 5 vertically 5 means horizontally also 5 will be there, because 1, 2, 3, 4 and this one 5. So 5 plus 5, 10. So 10 rectangles are there, 9 squares are there. So 10 plus 9, 19 are there, 19 quadrilaterals in total. So option C is the correct answer. Hope all of you understood this. These are few more questions. You can screenshot this and try it yourself for extra practice. So now this is a question where triangle number is asked. CSIR have asked triangle number 2-3 times. So this is one such question. All of you try this fast. Rectangle number, square number, quadrilateral number, triangle number, all these were asked. Parallelogram number also was asked once. Where we already discussed now, quadrilateral is a polygon which have 4 sides. Square is a quadrilateral, rectangle is a quadrilateral, parallelogram is a quadrilateral. Even in the last class when we discussed about 2D geometry, check out that lecture, we have shown examples of quadrilaterals. Trapezium is a quadrilateral. 4-sided polygons are called quadrilaterals. So I will start explaining. Due to lack of time, some of you already got an answer. Number of triangles here. Number of triangles, for convenience I will mark this A, B, C, D, E, F, G, H, I. Now ABC is a triangle. Now the non-overlapping ones you can count. ABC. ACD is a non-overlapping triangle. BCE is a non-overlapping triangle. CDE is a non-overlapping triangle. GHE is also a non-overlapping triangle. So 5 non-overlapping triangles already. Now the overlapping ones you can count. Overlapping ones, if you count, ABD is an overlapping one. This one. Then BED is an overlapping one. Then BFH is an overlapping one. And DGI is an overlapping one. And then ABE is an overlapping one in this direction. There is chances that some people may have missed this. Similarly, ADE is also is an overlapping one. Finally, the big triangle AFI, that also there are chances that we may miss it. So AFI. So counting all this, you have got 6 plus 5 plus 1, 12 triangles in total. 12 triangles in total. Hope all of you understood this. Please respond. Now, this was another type that was asked in CSIR-NET exam once. This is a little time consuming one. So try this. November 2020 this was asked. Simple versions of this are given here, but due to lack of time I will directly go to this question itself. Try this, all of you. November 2020 problem. As I told, last 2-3 years questions were asked frequently from this area. Before 2-3 years the number of questions from this area was very less, but last 2-3 years questions are frequently asked. Frequently asked means one question or two questions maximum. Normally one question. So here also a number of triangles are asked. Here systematically counting this, that is very important. Formula will not work. These kinds of questions don't depend on formula because it is all random situation. It is not like this type, this time they will ask this many rows, next time they will ask one row extra. If that was the case, you could have learned a formula for this type, this triangle type question only. Likewise for CSIR you cannot prepare. For some government exams you can prepare like that, because few types are frequently repeated, but for CSIR chapters are repeated but type of questions repetition are very less in number. So let's see, due to lack of time I will start explaining how many triangles are there in the figure. So the non-overlapping ones we will count just like the previous question. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. All of you understood this? There is a mathematical pattern also for that. First row 1, second row 3, third row 5, fourth row 7, fifth row 9. That means 2 triangles are added to the previous number. That is sum of first 5 odd natural numbers. In number system chapter I taught you sum of first n odd natural numbers will be n square. So 5 odd natural number means 5 square. That way also you can count this 25. Hope this 25 non-overlapping ones are done. Now the overlapping ones we will count. That means 2 row at a time. 1 row at a time we've counted. 2 row at a time. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10. 7, 8, 9, 10. That is 1 plus 2 plus 3 plus 4 it is. So 25 plus 10, 35. All of you understood till 35? Now the 3 row involved ones we will count. These three, 1, 2, 3, 4, 5, 6. That means 25 plus 10 plus 6. That itself is 41. Now look at the options. These 3 options are below 41, so that itself eliminates those 3 options. There you can stop your solution, but if you want to see the exact count, because this is 41, answer is above 41, that is why we got 48 as the answer. But let's reach 48 itself. How? Now 3 row involved we have counted, 4 row involved, 1, 2, 3. So 41 plus 3, 41 plus 3, 44. Now 5 row involved are there, the biggest triangle, this biggest triangle, that is 45. Still it is 45 only, na? It should be 48. Na? All these triangles are upright triangles, but there are upside down triangles also. There is an upside down world, like in the TV series Stranger Things. There is an upside down world also here, which we haven't counted 3 of those triangles. These upside down 2 row involved triangles were not counted. That is how 45 plus 3, 48 is 48 count is reached. So option D, 48 is the answer. All of you understood this? Little time consuming, but the options were comparatively easy, that when you reach 40 or above you could have stopped right away. All of you understood? These are few more questions on triangles for you to practice more. You can screenshot it and try it. This was a November 2020 problem where triangle, rectangle both were involved. Triangle, rectangle both were involved. Try it as homework. Solution is given here. Or in our other playlist, we have given a dedicated video on this also. And this was a very good question, but it is a time consuming question. This question also separately are discussed in the previous year analysis series we have done in this channel. So these are the major types. This is a GATE exam question. Those of you are preparing for GATE also these kinds of questions are asked, but little trickier way they have asked. But trickier means not very time consuming. You have to understand the question properly, that's all. GATE 2016 problem. Okay, we will discuss this type. This is the last type to be discussed. Try this question. Due to lack of time, I will start explaining. In a 2x4 rectangular grid shown below, each cell is a rectangle. How many rectangles can be observed in this grid? 2 row 4 column. So there is a shortcut formula. Due to lack of time, I will directly explain the formula. To find the number of rectangles in an m by n system. M by n system, that means m row n column. Here 2 row 4 column. Na? The formula is m plus 1 C2 into n plus 1 C2 for finding the number of rectangles. C means combination. In the permutation combination chapter, we have discussed about combination. That means in this question 2 plus 1 C2 into 4 plus 1 C2. That is 3 C2 into 5 C2. 3 C2 is 3. 5 C2 is 10. 3 into 10, 30 it is. 30. So option C, 30 is the answer. Due to lack of time, I am concluding this type here. Now, number of squares also can be asked. In the same question, instead of rectangles, finally, instead of rectangles, if it is squares asked, how you will find? For that, what you have to do is 4 into 2 you have to do. Then subtract 1 from both the numbers. 3 into 1. Then subtract 1 from both the numbers again. 1 into 0. 1 into 0 means it is 0. There you can stop. When you get 0, you can stop. 8 plus 3, 11. So 11 will be the number of squares. Yeah, I agree that as the number of, this is how the question can be asked. How many squares can be observed? As I told, 2 by 4, that is why 2 into 4 plus 4, 1 into 3 plus 0 into 2. There you can stop. That is 11. Is it clear, all of you? More questions similar to this. CSIR have asked this once. This was GATE, another question similar to this. You can try this yourself. CSIR have asked it in June 2013. There the question was asking how many rectangles which are not squares. That means you have to use both the formula I taught you now. First you have to count the rectangle using this formula. In this case, 4 row 4 column. So it will be 5C2 into 5C2. That is 10 into 10, 100 it is. From that you have to subtract number of squares. Here it is 4 into 4 plus 3 into 3 plus 2 into 2 plus 1 into 1 plus 0 into 0. Due to lack of time, I am just calculating it. It will be 16 plus 9, 30 finally. So from 100 you need to subtract 30, because in this 100, as it is, the formula is giving number of rectangles. In a previous question I already told you, rectangles means squares are already included in it. But in this question, which are not squares are asked by CSIR. That is why rectangle number minus square number. So 100 minus 30. 100 minus 30 you need to do here. 70. This is another version of this formula. No need to learn more formula. What I taught you now is enough. This is for this is a special case of that formula itself. All of you understood it? Briefly I have mentioned that type also. These are the types of questions that are asked from this area. Hope all of you understood. Hope this session was useful. If so, do share it with maximum people and do let others know, especially about the GATE course we told. If more people are there, then only we can launch that course. So do let your friends know about that course. We are trying to see whether more students are being part of the platform. If more people are being part of the platform, more classes will be there through the platform. As I told, I am part of other initiatives also, or other institute classes also. So along with that, I am running these classes also. So if people are interested to be part of our platform, our individual platform will be running more. Otherwise, more classes through institutes will be there. So if you want more classes through our platform, Christy's classes platform, do support us and do let others know about the classes in this platform. So let's conclude here. Hope today's session was useful. If so, do hit the like button. Thank you. Take care. Bye bye.